Our moon, a celestial companion to Earth, has always been an object of fascination and wonder. For centuries, scientists have pondered its origins, piecing together the story of its formation. Now, groundbreaking research suggests that the moon might be older than we previously thought, born from a cosmic dance that unfolded billions of years ago. The prevailing theory for lunar formation, known as the giant impact hypothesis, posits that a Mars-sized object collided with the early Earth around 4.51 billion years ago. This cataclysmic event ejected a massive amount of debris into space, which eventually coalesced to form our moon. However, recent studies utilizing advanced dating techniques on lunar samples have put forth a new timeline, suggesting the moon formed much earlier, around 4.53 billion years ago. This revised timeline has significant implications for our understanding of the early solar system and the evolution of Earth itself. This new timeline, if confirmed, would rewrite our understanding of the early solar system. It would mean that the moon formed in a much more chaotic and active period than we previously believed. Further research and analysis are needed to confirm this new timeline and to fully understand its implications. However, the possibility of a much older moon is an exciting development that could revolutionize our understanding of our celestial companion and its place in the cosmic order. The prevailing theory for the moon's formation, known as the giant impact hypothesis, paints a dramatic picture of the early solar system. According to this hypothesis, a Mars-sized object, often referred to as Theia, slammed into the young Earth approximately 4.51 billion years ago. This colossal collision released an immense amount of energy, heating both Theia and Earth to extreme temperatures. The impact ejected a massive cloud of vaporized rock and molten material into space. This debris, caught in the gravitational pull of the early Earth, gradually coalesced over millions of years to form the moon. The giant impact hypothesis elegantly explains several key characteristics of the moon, such as its relatively large size compared to Earth and its composition, which is similar to Earth's mantle. While the giant impact hypothesis remains the leading explanation for the moon's formation, the new timeline proposed by recent research introduces a wrinkle in this well-established narrative. If the moon formed earlier than previously thought, it raises questions about the timing and nature of the giant impact. Scientists are now exploring various scenarios to reconcile this new timeline with the existing evidence. One of the key pieces of evidence supporting the new timeline for the moon's formation comes from the analysis of lunar zircons. Zircons are tiny, incredibly durable crystals that form in magma and are capable of surviving for billions of years. These crystals act as time capsules, preserving within them a record of the conditions present during their formation. Scientists have dated lunar zircons brought back to Earth by the Apollo missions and found them to be surprisingly old, with some dating back 4.51 billion years. These findings suggest that the moon's surface solidified much earlier than previously thought, lending credence to the idea of an earlier formation. This new timeline challenges the traditional view of a global magma ocean covering the moon's surface for an extended period after the giant impact. The presence of these ancient zircons provides compelling evidence for an older moon, but it also raises new questions about the nature and evolution of the lunar magma ocean. Scientists are now investigating whether the magma ocean solidified more rapidly than previously thought, or if it existed in a different form than initially theorized. The new timeline for the moon's formation also has implications for understanding the evolution of its surface features, particularly the number of impact basins. The moon is scarred with countless craters, evidence of a tumultuous past, bombarded by asteroids and comets. However, compared to other celestial bodies in the solar system, the Moon has relatively few large impact basins. This observation has puzzled scientists for decades. One possible explanation is that the Moon experienced a period of intense bombardment early in its history, followed by a period of relative calm. This period of heavy bombardment, known as the Late Heavy Bombardment, is thought to have occurred between 4.1 and 3.8 billion years ago. If the Moon formed earlier, it would have been exposed to the early solar system for a longer period, potentially increasing the likelihood of impacts. However, the relative scarcity of large impact basins suggests that the rate of impacts might have been lower than previously thought during this early period. This finding could have significant implications for our understanding of the dynamics of the early solar system and the evolution of planetary bodies. This new research, while still in its early stages, has the potential to reshape our understanding of the Moon's formation and early history. The discovery of ancient zircons and the implications for the lunar magma ocean provide compelling evidence for an older Moon. This revised timeline challenges existing theories and prompts us to reconsider the timing and nature of the giant impact, the evolution of the lunar surface, and the dynamics of the early solar system. As scientists continue to explore lunar samples and gather new data, we can expect even more surprises and a deeper understanding of our celestial companion.